Welcome to the Coatings Talk live chat podcast. I'm Jim Kunkel. I'm a certified protective coating specialist with over 15 years in the global protective coatings industry, and I greatly appreciate everyone joining in on this live chat recording session. As we're getting started, I'd like to cover the session disclaimer. This live chat podcast in the Coatings Talk series does not represent the opinions or strategies of AkzoNobel International. I'm recording this session audio for rebroadcasting as an audio podcast for the Coatings Talk channel. Now, before I set up today's topic, I'd like to cover how you can participate in this live session. It's real easy. All you have to do is use the raise your hand icon in the chat menu. And also, please feel free to hit any emoji to let me know how you're feeling about this live session. Our topic is Icri CSP 310.2R-2013. In addition to talking about the Icri CSP, I'll also be talking about aspects of surface preparation for concrete and a couple other standards to mix into there as well. Okay, let's get this started. ICRI Technical Guidelines number 310.2R-2013 is selecting and specifying concrete surface preparation for sealers, coatings, polymer overlays, and concrete repair. Now, it also includes visual standards to act as a guide in defining acceptable surface profiles for the application of industrial coatings and polymer floor coverings. This industry consensus technical guideline summarizes the capabilities, operating requirements, and limitations of the various methods used to prepare concrete surfaces for the application of protective sealers, coatings, polymer overlays, and concrete repairs. Now, the benchmark profiles are included, which provide visual standards for the purposes of specification, application, and verification. And in the 2013 version of the guideline, you'll find surface retarders and handheld breakers have been added to the surface preparation methods. Surface preparation methods have been updated, and the appendix summarizes considerations for selecting surface preparation methods and describes various test methods used to evaluate the prepared surface, plus concrete surface profiles, which are the CSPs. There are 10 of them, and they've been added to reflect more aggressive CSPs used for concrete repair. So let's get into the topic. Concrete is a versatile and durable material that's widely used in infrastructure projects such as buildings, bridges, roads, tunnels, wastewater treatment plants, and more. It's a composite material made up of cement, water, and aggregates such as sand, gravel, or crushed stone that hardens over time. Concrete is used in infrastructure projects because of its strength, its durability, and the ability to withstand harsh weather conditions. Now, that being said, concrete over time is very susceptible to deterioration by harsh environments, natural and man-made corrosive materials, abrasion, and weathering. In recent years, researchers have been exploring ways to make concrete more sustainable and environmentally friendly. For example, some researchers are developing self-repairing concrete that can fix cracks on its own, from plastic shrinkage, expansion cracks, and premature drying. The concrete industry is also experimenting with using recycled materials, such as fly ash and slag in concrete production. The concrete industry is also poised to benefit from the $1 trillion infrastructure plan that was approved by the U.S. federal government. The plan includes funding for the repair and modernization of roads, bridges, and other infrastructure projects across the United States. Surface preparation and cleaning of concrete substrate is generally considered the most crucial step in a concrete coating project. A poorly prepared surface will always be the weak link in not only coatings application, but also concrete repair that might be needed prior to new coatings application. Surface preparation includes the removal of damaged and or deteriorated parts of the substrate concrete, and previously applied coatings. Concrete cleaning commonly refers to the removal of loose surface contaminants, materials, particles on the concrete surface. Surface cleanliness is also very important in concrete repairs, as any loose debris, dirt, grease, or other surface contaminants can act as a bond breaker between the concrete substrate and the coating system being installed. Obtaining a sound and clean substrate requires quality workmanship. Coatings manufacturers' data sheets and engineering recommendations made from research on bond durability are meaningless unless proper site practices can be ensured. Now, please remember that concrete surface preparation is an essential step in ensuring the coating system's application meets project requirements and the completed project works meets minimum quality assurance inspection by the asset owner or hired third-party coatings inspector or inspection firm. Here are some minimum considerations related to concrete surface preparation prior to coating systems installation. The first is equipment for proper surface preparation. You can't start surface preparation without the right equipment. This includes equipment such as grinders, abrasive blasting units, shot blasters, scarifiers, high and ultra high pressure water jetters, scabblers, milling, roto milling units, and depending on your project needs, you might also need a power planner for large jobs or an angle grinder to smooth out rough edges. Second, you want to survey your surface before preparing concrete. Before you start any surface preparation, it's a good idea to get a full survey of the area. This means walking around and checking for cracks or other major damage that will need to be fixed before you can pour your new concrete or do work on it. You should also know where rebar is located in the foundation so that when it might be exposed during prep work, it won't interfere with form work installation later on down the line. And additionally, related to coating systems, you want to do a survey as well to assess the condition of the surface before surface preparation and coating application. Number 3, remove debris from surface. After documenting and photographing all areas of any concern, add time to remove debris such as rocks and other type of potentially growth laying anywhere near that project site. Now, this can save you a lot of headaches down the road. If you have an area with loose dirt, rocks, and biological contamination or growth, and you don't get it cleared away, that will cause an issue. Fourth, you want to remove existing coatings. Existing coatings on the surface should come off before new repairs and coatings application. Removing coatings will allow new concrete to properly adhere and bond to the concrete substrate. Also, keep in mind that some contaminants may not immediately be visible or could linger underneath. Old coatings, certain previous repair materials, etc. So the industry recommends getting rid of them to play safe. Number 5, surface roughening for concrete. Now, once you've gone over the surface and removed any loose debris, it's time to start preparing the concrete substrate. Your first step will be to roughen up your concrete or to prepare your concrete based on what is required so that new repairs to the concrete surface and coating system installation can adhere effectively. Now let's talk a little bit more about ICRI guideline number 310 and the guidelines associated concrete surface profile characteristic techniques. The concrete surface profile, or CSPs, as they're known in both the concrete and protective coatings industry. These are visual observations or comparators of surface roughness, and it's one of the simplest evaluation methods. But it is rather subjective to the inspector's or viewer's experience and practical knowledge of concrete substrates, and also concrete repairs, surface preparation, and coatings application. So it's very important anytime you are working with anyone who is doing assessment or inspection or application that they're very knowledgeable and have experience working in and around concrete for surface preparation, application, and inspection. One way of describing surface preparation is by comparing the substrate surface roughness with the various other surfaces, such as the ICRI CSP visual comparators, which assigns a concrete surface profile, a CSP number, based on the coating to be applied. The document further defines profiles with physical replica specimens prepared with different surface preparation techniques. The higher the CSP number, the more aggressive the profile. Another method of describing surface preparation techniques is by mechanical application or use of concrete removal or treatment. Machines that can be used include that will clean, that will also deal with other types of surface conditions. Now, a lot of this is listed in ICRI 310 guide, and it also compares the different surface preparation techniques that are used to achieve proper surface roughness related to profile for specific coating systems. The coating manufacturers will list a CSP that that's being targeted to have before the application is done. Now next, I'd like to cover information reference from SSPC SP13 NACE number 6, which is the surface preparation of concrete standard. And also too, I want to talk about one of the newest, which would be December of 2019, a newest standard, one of the last standards issued through SSPC, which is the SSPC SPCAB, and these are the abrasive blast cleaning of concrete. Now, a cornerstone of a lot of specifications is the SSPC SP13 NACE number 6. It is highly specified as a standard for the surface preparation of concrete. It's an industry consensus standard and provides the requirements for surface preparation of concrete by the use of mechanical, chemical, or thermal methods prior to the installation, which is the application of bonded protective coatings or lining systems. Now, this standard's requirements are applicable to all types of cementitious surfaces, including concrete floors, walls, masonry walls, precast slabs, and shotcrete surfaces. The ultimate goal of the standard is to arrive at an acceptable surface prepared concrete, and that surface should be free of contaminants, latents, loose adhering concrete, dust, and importantly, providing a sound, uniform substrate that is suitable for the installation, the application of protective coatings. Let's talk about what it means to have sound, clean, and dry prepared concrete. So let's break this down by each word. Sound refers to the unsound areas of the surface layer of the concrete. These unsound areas in most cases will need to be removed and repaired with materials which are comparable with the coating system so that it can be installed. Cleaning focuses on oils, grease, dust, food, dirt, chemicals, and biological contaminants as well, and growth, and other incompatible substances for coating systems. These must be removed prior to the coating. Dry is very important because most coatings require a dry surface for proper adhesion and a maximum level of moisture emission. Moisture in concrete migrates upward and outward through pores within the concrete. The amount of moisture that migrates can, in many cases, work against adequate coating adhesion. Some basic methods used to remove contaminants typically include detergent scrubbing, low pressure water jetting, degreasing solutions, and in worst case scenarios, the removal of all contaminated concrete. When using detergent and chemical solutions, it's important to completely re-clean the concrete surface with fresh, clean water. These basic methods of cleaning can be used to address concrete contamination by soluble salts, efflorescence, and removing mildew. The standard also provides much more detail and information on industry recommended methods of surface preparation of concrete. Grinding is used as a primary method to remove surface irregularities on the concrete surface, and it's used to create a surface profile on the concrete. It's a great method to remove old coatings and, in certain cases, unsound concrete surface areas. Dry abrasive blast cleaning can be achieved with the use of conventional open-air driven equipment that uses abrasives identical to those used during surface preparation of steel. To control dust, many projects require the use of vacuum collection air-driven equipment that's very similar to conventional abrasive blast cleaning equipment, but adds a vacuum system to collect spent materials and surface debris. The majority of blast cleaning of concrete floors uses a shot blasting system. Wet abrasive blasting, as the conventional abrasive blast cleaning that I mentioned earlier, It adds accessories, a water ring donut or dual use dry wet or specific wet abrasive blast cleaning system that can be used. In my opinion, for contractors, it makes economic sense to use dual use dry wet blast cleaning systems as projects specifically might only require dry and or wet abrasive blast cleaning. Scarifiers come in handy for coatings and surfacings which are greater of 15 mils dry film thickness. This equipment has cutters which look like tooth washers and are assembled on steel rods which are mounted on a rotating drum that will pulverize the concrete surface. Scarifiers are very good for corners, edges, and those areas that shot blasting will not adequately prepare the concrete surface. Scabblers impact the concrete surface with piston-driven cutting heads at right angles to chip up and pulverize concrete floors. Operators of scabblers must be mindful that using the equipment to prepare the concrete floor, there's a higher chance of micro-cracking of the concrete surface, which can result in a weakened substrate, and as a result of coarse aggregates are fractured without being dislodged or removed. And then high and ultra pressure water jetting. This uses water pressures of 10,000 to 45,000 psi to remove weak concrete and tightly bonded existing coatings and surface overlays. Operator experience, training, and certification is important, as the use of high pressure water can damage sound concrete and transform good concrete into problematic concrete that requires potentially extensive repairs. Interestingly, earlier today on a work call, I was covering the SSPC SPCAB abrasive blast cleaning of concrete and cementitious material standards that was released by SSPC, the Society for Protective Coatings. That's the legacy organization that with NACE International merged to create AMP. But this consensus standard was actually released on December 1st, 2019. It's a set of 3 industry consensus standards which define 3 levels of surface cleanliness for concrete and cementitious materials through the use of abrasive blast cleaning to achieve surface preparation. Now, all 3 standards mainly center on 2 criteria related to the extent of removal of existing coatings and to extent to which surface air voids are open. So as a result of the requirements of the 2 criteria, the 3 standards can be simply defined individually as SSPC SPCAB1 having the highest degree or level of concrete surface cleanliness or thorough blast cleaning, the SSPC SPCAB2 as an intermediate blast cleaning, and the SSPC SPCAB3 as a minimum brush blast cleaning. So these 3 standards can actually be invoked in a lot of projects where you might have a varying degree, where you might need more aggressive surface preparation or a lesser degree of surface preparation of concrete. Now, all 3 standards have a common requirement for the complete removal of all unsound surface materials, all efflorescents, and latents. Additionally, all 3 standards set the basic requirement of conducting a visual inspection of concrete surfaces, which is to achieve and verify the resulting condition of the concrete structure surface. And all 3 SSPC-CAB standards are streamlined and only have 5 pages for each standard. Importantly, all 3 are very impactful for owners of concrete structures and assets, industrial coating contractors, coating manufacturers, and the general concrete industry involved in concrete preparation and concrete repair. So this wraps up this conversation on ICRI CSP 310, and I highly recommend additional consideration of the specification of SSPC SP13 NACE number 6, which is the surface preparation of concrete, and the SSPC SPCAB standard series, which can be specified for the surface preparation of concrete when the use of abrasive blast cleaning is required. And further specific, the SSPC SPCAB standards can be individually required within project requirements. Okay, everyone, have a great evening, day, or morning, no matter where you're listening from. Thank you.